Let's talk about KCL, Kirchhoff's current law. It was given by German physicist Kirchhoff. So basically, let's take a circuit, arbitrary one. So the law states that at any node is where more than two branches are connected. So we can see here 1, 2 and 3. So this is a node, this point. So at any node, the sum of entering currents will be equal to the sum of leaving currents. That means, let's say this current is I1 coming here and leaving currents are I2 and I3. So according to Kirchhoff laws, I1 will be equal to I2 plus I3. It is sometimes stated in such manner, let's say entering currents are positive and leaving currents are negative. So I1 is the positive current and leaving currents are negative. Sorry, this is also negative. So the sum of the total current will be 0. So entering and leaving current. So basically sum of it's easier to state it this way, that the sum of entering current is equal to the sum of leaving currents. So, and it comes from the conservation of charge, because whatever charge, the charge has to be the same, and we know that Q1, the total Q has to be it has to be the same. Whatever charge is coming here total charge has to be same. So basically Q is given by IT, we know. So T will be of course same for everywhere. So basically this one from there, if I replace the I, so Q1 will be equal to Q2 plus Q3, and then if the T is taken away, it becomes I1 is equal to I2 plus I3, like that. So that's the Kirchhoff's current law. At any node, the sum of the entering currents will be equal to the sum of the leaving currents. And then there is an equivalent another law for voltage, Kirchhoff's voltage law, given by Kirchhoff again. This one is coming from, this one states like in any closed loop, let's say this one, in a loop, the total sum of voltage drop is 0. That means let's say this one is, the voltage is here, this one is here, and here. So if we have the current in this direction, so this is E, this is V1, V2, V3. This one can also be stated like this, that the sum of the voltage rise is equal to the sum of the voltage drop. If we say that, it's E is equal to V1 plus V2 plus V3. So this one is a rise. And why this is a rise? Because if we traverse in this direction, we can see that this is, when we go this way, it's a negative towards positive, so that's a rise. So this is rise here, and when we go in this direction, they're all plus to minus. That means these are drops. So the drops are in this direction, in this side. So the sum of rise is equal to sum of the drops. It can also be, sometimes it's stated this way, that sum of voltage drops are 0. So when that's said, it actually means the rise is a negative drop. So basically when we go in this say any arbitrary direction, let's say this direction, clockwise counterclockwise direction. So if we go CCW, we can see that this one is a rise, E is a rise, so it is a negative drop, and then V1 is a drop, plus V2 is a drop, plus V3 is a drop. So sum of voltage drops, algebraic sum of voltage drops, that's what it said, is 0. So when it said algebraic sum, we have to understand that the rise is a negative drop, and the voltage drop, which is the drop, is a positive drop. So it can be stated in these two ways. One is like the sum of the algebraic sum of voltage drop is 0, or it can be said like the sum of voltage rise is equal to sum of voltage drop. So both are same thing basically. And this is also coming from conservation of energy, because we know energy or work is energy, so is QV. So the total energy has to be conserved in a circuit. So if this is this one W1 will be equal to, so if we can call it, let's say WE, this one, this one's energy associated to this one, and this one then W1, W2, W3. So basically no energy has to be created. This energy is dissipated here in these three registers. So again the Q is same everywhere. So if we get rid of the Q, we get V here, or this V, this is actually E here, the rise, and then V1 plus V2 plus V3. And similarly, as I didn't say, the Kirchhoff's current law is sometimes stated as algebraic sum of entering current is 0. Entering currents is 0. So basically, in that case, the entering current is stated as a plus current, and the leaving currents are stated as negative currents. So it can be stated like that. But then also we have to say the algebraic sum of the currents, of the entering currents, is 0. That's the thing. Or it can be said the sum of entering current will be equal to the sum of the leaving currents. So sum of the entering current is equal to the sum of leaving currents. So it's basically the same. So these two are very important laws along with Ohm's law, and this will, then we can do some circuit problems later on.